Good morning, everyone. Welcome once again. And have you got the table I told you, the previous table we had? It's the reference table we are going to use. So today I want us to discuss on what we call the ogive curve. Like I mentioned last time, we are going to use the same table. Then when time allows, we shall also introduce non-uniform class width. So we are going to sketch what we call the ogive curve. Sometimes this we call it the cumulative Sometimes we call it the cumulative frequency curve. The reason why it's called the cumulative frequency curve, it's because we use cumulative frequency to plot it against the upper class boundaries. So get your graph papers. We are going to plot on a graph. I'll also plot here. We shall have upper class boundary, upper class boundaries against cumulative frequency. That's why you find some books having CF. So who recalls our table?
Link eno sinakikuterayo ku peegi wabula osobola okulabira
Hello.
Teacher, your mic is muted.
Sorry, I was saying, guys, I expect you to plot these points, which look like this. And then I expect you to sketch a curve which looks like that. The upper class boundary begins from 54.5, but you can start with this starting value as 44.5. But having it in mind, you're plotting the upper class. You don't plot the lower. Or you can start with straight away 54.5. When you start with 54.5, it will start exactly somewhere here on the axis. Let me show it to you. If you start with 54.5, then 54.5 will be here. Then you follow it with 64.5. Then you go with 74.5, 84.5, then 94.5, then 104.5, then 114.5. So it will start exactly here. So because the first value of the frequency is given, what is the first value of frequency? The first value of frequency is, what is that first value of frequency? It is what? It is 1, eh?
Yes.
So if it is 1, your 1 can be somewhere here. If your 1 is here, it
Yes.
means the curve will start from the axis. That is if you've started with 54.5. But if you start with 44.5, it will be somewhere away from the axis, like around there. So I want you to give me that shape. Let me also try to sketch one here so that I can share mine also with yours. Those of us who do not recall, the cumulative class boundary was having 1, 2, was having 1, 2, 4, 10, 31, 60, 84, 96, 100. And this was between, there was a class boundary, which was 44.5 to 54.5, 54.5, 64.5, 64.5 to 74.5, 74.5 to 84.5, 84.5 to 94.5, 94.5 to 104.5, 104.5 to 114.5, 114.5 to 124.5, 124.5 to 134.5. So we are plotting the upper class against the cumulative frequency. So we are plotting this line, this one, with this one. So can you plot, guys? Those of us who are not there and you never do the table, distribution table, that's the distribution table we are looking at. So I want you to sketch the curve. After sketching the curve, you let me know. Then I take you through how to get the median, upper quartile, lower quartiles, and the line. But as I'm also doing mine here.
Teacher, when do we start drawing from the axis, from the y-axis?
We start from the y-axis if the 54, this one. Let me first admit this person. If this value is the one you're starting with here, but if it is starting with 44.5 like this one, then this value is slightly away. So the starting point will be here. But if this is the beginning point on the x-axis, then the first point will be on the axis. That is the point of having what? 54.5 plotted with 1, the first one. It will be exactly here. Then the curve will follow something like that. But if it has not started from 54.5, it has left there some space, and it began with 44.5, then 54.5, then the axis will be here, then the first point will be displaced away, which is a point around here. Then to start from there, then it forms our shape. Is that clear?
Yes.
Okay, please go ahead and sketch. Others, please also do make consultations in case of any challenge. Can someone give us an idea of their scale? What scale have you used on the x-axis for better scaling?
10 with 2 big boxes.
10 with 2 big boxes. So it means if I start with 44.5, I'll have here 54.5, 64.5. But in the middle here, there are 2 big what? Boxes. Okay. Then on the vertical axis, what have we used?
10 with 2 big boxes also.
10 to 2 big boxes, whereby this is 10. So one smallest box represents 1. Eh? Not so?
Yeah.
Until you reach what?
Yes.
100.
Uh-huh.
But remember to always go beyond 100. At least you can go as far as 110 for a better scale. Okay, then people are on the right track. So can we proceed?
No, please.
The best way to sketch a smooth curve is by turning your paper and start from up rather than from down. Someone has a hand up. Teacher, my first math lesson in this program, I'm wondering why 2 graphs. Yes, someone's asking me, this is Kevin Murungi, a new student, you're welcome. Teacher, my first lesson in math, this program, I'm wondering why 2 graphs and why the other is starting from away from the y-axis while the other is starting from the y-axis. Are the 2 graphs a similar way of answering the question? First of all, yeah, Kevin, both answers are correct. But the thing is, one can start from the axis. The reason why you start from the axis, someone asked the same question before. If I begin, because we are plotting, this is the upper class boundary. This is the lower class boundary. In the ogive curve, we plot the upper class boundary. You will ask me for the videos in my inbox. This is my WhatsApp number, so that I send you some of the videos of what we covered before. I was saying, if I started with 54.5, the first point I plot it with is 1. The 1 will be somewhere here, the first smallest box. Of course, we are saying we are using 10. So this first smallest box will be here. So the first point will be plotted exactly there on the axis, right? Then the curve will begin from the axis and then it will go and form such a shape. While if I did not begin with 54.5 on the x-axis and I began with 44.5 just to cover up this part, but I'm not plotting the lower class boundary, I'm plotting the upper class boundary. So it would imply the 54.5 is around here, then I have 64.5, then 74.5, and so much and so forth. So with this time round, the 1 will be plotted, it will be around here. Then you plot it around there, it will start from there, then it goes and forms our shape. That is why the 2 items differ from where they start from, but they will give us the same answers. Okay? So in your free time, investigate both. If right now we have done using moving away, in your free time, investigate starting from the wall. Okay? So Mr. Kevin, is it Kevin or a lady or a man? Kevin Murungi, are you fine now? Is it a better explanation for that? Charinda has a hand. Priscilla, you also have a hand up? So guys, I was saying the best way to plot this graph better is by turning your book and start sketching it from up rather than from down. For me, the whiteboard, I can't turn it around. So I'm going to start also from up on my paper, because I'm also doing the same number on paper. And I want to share it with you. So I've sent my shape on your WhatsApp. I'm also going to share it on the screen. Did you guys refer? Kabagaju. Kabagaju has a hand up. Yes, Kabagaju. Kevin, it means you can answer the question either ways. Yes, please. Kabagaju, your hand was up.
That we can turn the graph paper, yeah, but then, yes, I'm saying You said if we are to draw this graph, we have to turn the paper, but then on the
No, I'm saying you guys
it's
can turn
a
your
bit
graph paper.
shorter. It can,
It becomes what?
yes, but then if you turn it, you can't really get 100. You can't get 110 as your highest value on the y-axis.
Hey, wait, your scale does not exceed 100, eh? On the y-axis.
Yes.
It's okay. You can
like
start from
90.
100. Start from exactly 100 and go back.
Okay. Okay.
You're welcome. I'm trying to share my graph so that you can take a look. And I will use my graph for reference to answer the questions. Then each of you should share your graphs in the group so that I can take a clear look of what exactly most of us have done. So here I am. Here comes my graph. Kevin, I wrote my number on the other screen so that you can WhatsApp me. There's a math group where most of us are. So guys, this is how my shape has come out. So Kevin, you see what I was explaining? Now, according to my graph, I've begun from here. I have begun from, I've begun from 54.5. That first value is 54.5. Then we said 1 is represented by 1 small box, because if these are 10, then the smallest box here is 1. So my 1 is exactly there. So my shape has turned out to be like that. Someone has a hand. Habiba, you've only copied 9 digits. I can reshare the screen. My number is right there. My number is right here. This is my WhatsApp line, which I will use to add you to the math group. Habiba, now I think you can complete the digits you need to complete. Okay, I want to go to the now and we use it to answer questions.
I'm done, thank you.
Okay. Those of you who have started with 44.5 on the x-axis, yeah, it is okay. Stephen Mugera, if you begin with 44.5, it is very fine. It's just that your graph will not be starting from, your graph won't just start from here. The graph won't just, it will start from somewhere like here. What happens is you just shift this point this way. So the point will be around here, then the graph starts from there. Now, can we start answering the questions? The first question is going to be the median. Yeah? The median. If you remember the median we got last time, we shall refer with the one we are going to get today. The median is got from what? It's got from the cumulative frequency or the total frequency, which is summation f divided by 2. Okay? When you divide by 2, you get what? It is 100. So divide 100 by 2. What do you get? You get 50. Now we move to our axis here. Hey, go back. We move to our axis here and look for where 50 is. 50 is after 40. Okay? 50 is after 40. So you look for 50. I'm looking for how to move this down. Now where is my 50? My 50 is right here, not so. So you get a rule, a rule and a pencil, then mark dotted lines along this line, or just trace with a ruler. Come here and locate where the 50 crosses the x-axis. I mean the curve. After noting where 50 crosses the curve, then draw a vertical line to the bottom. Draw a vertical line now to the bottom, and we read that value. My curve has shifted, sorry. Let me draw another one here. So we have said our 50 is here. See that? It meets the curve from there. Then draw that vertical line going down. You can draw with a pencil, or you can just match with a ruler. And then go down and read the value down there. So What value do you read? Read yours as I also read mine here. Where is my 50? My 50 is here. That's crossed on the second one. Has it crossed on the small second box? Small box?
Yes.
Guys, we must be getting the same results. Eh? You might, what I'm getting, mine is at the second smallest box. Hope all of you are at that. Now,
Yes,
can you
teacher.
go down?
Yes.
If you're not, you have a problem somewhere because all of us are agreeing. So you have to go down now. Down it reads, the middle part is what? 94.5, 95.5, 96.5, 97.5, 98.5, 99.5.
101.5.
101.5. We get that?
Yes.
Guys,
Yes.
yeah, it is
Yeah.
reading 101.5, not so?
Yes.
Okay, if you deviate a little, it is supposed to be plus or minus. So 101 is correct, 102 is also correct. Anyone who has an answer outside 100 and 102 is off the course. Okay? Now, can we refer to the number of the median last time? Refer to the median last time. What did we get?
We got 101.
We got 101, eh?
Yeah.
You see, we are in the same range, okay? The rest, are we also there? Boys, I don't hear any sound from you. That's why girls get 100 in this paper. Because they are patient, they are careful. Boys assume they know these things. And then they cane them so badly. All the answers are coming from ladies. Ladies, that is a very good job you're doing. So can we now go for the quartile? The quartile is going to be a quarter of n. That was median. Lower quartile. Q1 is going to be a quarter of the summation of F, which is a quarter of 100, and the answer is 20 what? 25. So come and look for 25. 25 is here. Then match this line. It's stopping somewhere there. Then go down and read the corresponding value. After this work, we shall go for another graph work, which is called scatter diagrams. So keep your graph books closed. Don't throw them away. We are having what? Lower class boundary at 25. 25 is crossing through the third box after the middle of the biggest box. '85, '86, '87, '88, '89, '90, '91, '92. Can I hear your answers?
91.5.
90 what?
91.5.
90.
Another one?
92.5.
Should be 92.5. If you have deviated a little, it should be 92. If you have deviated more, it's going to be 90, 93. That is plus or minus 0.5. So the lady who got 91, maybe the curve was not a little bit smooth there. Or you're considering it passing between 92.5 and 91.5. So that is how we get the lower class what? I mean the lower quartile. Yeah. Now can we go for the upper quartile? Hey, what did we get in using a histogram?
91.5.
Wow. Okay. Let's assume all the answers are ranging between 191.5 to 92.5. Of course, plus or minus 0.5, 91.0 and 93 can be inclusive. The upper quartile. The upper quartile is got from 3/4 of n, right? Which gives us 3/4 over 100. By 4 once, by 4, 70, 25, not so? So the answer gives me 70 what? 5. Now come and locate 75 here. Are we there? Then move with a ruler. We've had finally one man, he has come. The rest of the men are quiet. Then it is meeting here at the second box, I think, first small box. Then draw this line down. Sorry, you know, I'm using a screen, so I'm over shaking. But it is shaking somewhere around here.
Yeah, it does screen teaching.
75, let me see. Mine has gone in the middle. I think the screen was not displaying it well.
110.5.
104, 5, 7, 8, 9, 10. Between 109.5 and 110.5.
The 10.5.
Yours is 10.5. Yeah, 109.5 plus 110.5. When I divide by 2, the answer gives me 110. But plus or minus 0.5. So 110.5 is correct, and also 109.
110.5.
Yeah, you are correct.
Yes.
Even 109.5. Yes, I was saying, guys, the 75 has landed on somewhere around here. No, that is 70. 75 is around there. And according to mine, I got 109.5 plus 110.5. It was between those two. When I get the average, I get 110. But like I've said, plus or minus 0.5 is correct. So it ranges between 109.5 to 110.5. Those of you who are not there, how do we know that we have to get the average? If the number lies here, like look at this small box. You see this one and this one, and the curve is cutting there in the middle. Then read this value, also read that value. Then get the average in the middle. That would be the average coming from the addition of those two values, and then we divide it by 2. So that is the upper quartile. Then you can from there get what we call the semi-interquartile. Interquartile what? Range, which is equal to the upper quartile. This one sometimes we call it 2/3. The upper quartile minus the lower quartile divided by 2. Okay, so that's called the semi-interquartile what? Range. Of course, the answers you'd have got them. Today's intention has been, I think, hello guys. Today's intention has been captured. That was looking at the ogive curve. But now next time, there's another class. Did the teacher discuss non-uniform class width, which is using the frequency density. Have you ever heard of the frequency density? Guys, have you heard of the frequency density? Students, I'm asking you, have you ever heard of the frequency density? Guys, I was asking, have you heard of the frequency density?
No, teacher.
No, teacher.
Okay, then that
Yes.
means next time, yes. Someone has said yes. At school,
No.
No, that means
No.
next Wednesday. Okay, listen. Next Wednesday, I will bring a number which has frequency density. Then it also requires plotting. Because for that number, someone mute your mic.
Okay.
For that number, to look at a histogram, which histogram will be in the way that it will look at a histogram of this kind. It can have a very big radius, width here, a very thin width, but a long height. Another one can be like that. Another one can be this long. Another one can be this big. Another one can be another one small. So this is non-uniform class width. Here we have been looking at uniform class width. These ones have been uniform, that all of them have a difference of 10, 10. So I'm going to send some write-up on frequency density. You note it down. Then you also have a table, which table I'll take reference from, so that next time we don't wait. As you can see, the whole hour, we can only take 1 hour to discuss one entire graph. So if I don't send the information earlier, it is a challenge. Now let me send more numbers on that to try out on the histogram and the what? And the ogive curve. But the other last bit I wanted to comment on this ogive curve. Sometimes they ask for what they call percentiles. They can ask you for a percentile. They can say 10th percentile. 10th percentile means 10 out of 100 of the out of the total frequency, which would give you 10 out of 100 times 100, and the answer is 10. So you come and look for the 10 here, match it on our curve like we have been doing, then read the value where? Down. They can say the 70th percentile. 70th percentile would mean 70 out of 100 of the total frequency. Yeah. The network has start becoming unstable, but the good thing, it has unstabilized when we have our main issue covered. So I'm saying this business of looking at percentiles, what I've discovered, I'll design a number to only come and discuss percentiles. 80th percentile, 70th percentile, using the ogive curve and the histogram. Of course, the histogram we use area like we did before. Then for the histogram, we use the total frequency. Okay. Then before that, I'll have to discuss frequency density. So let me send right up of frequency density now, and I'm also going to send you some 2 numbers to discuss. Also, I hope the teacher mentioned this, that in case the numbers are not whole numbers, yeah? If the numbers were not whole numbers, like the table has, like if the table has what? If the table has something like this, the table has like 50 to 54. On cumulative frequency, we add or subtract 0.5, which is 49.5 to 54.5. This is class boundary. This is the class. Now, what if the class has 50.2 to 54.2. It means we subtract on or add on 0.25, which is 50 minus 0.25, 0.05, you get 50.15 to 54.25. Here we add or subtract 0.05. Here we add or subtract 0.5. In case it is 3 decimal places, in case the class has 50.25 to 54.25, then the class boundary becomes what? You subtract off or add on 0.005. Okay? So when you take off 0.005,